Every time you ask an artificial intelligence a question somewhere in the world, a building the size of 10 football fields consumes enough electricity to power 50,000 homes during that fraction of a second. You don't see it. Nobody talks about it. But without it, the internet disappears in 48 hours. This is the story of the most important infrastructure of the 21st century and the silent war to control it. A data center is, in its simplest form, a building full of interconnected servers. But modern data centers are anything but simple. The so-called hyperscalers, built by Amazon, Microsoft, Google, Meta, and Apple, are massive industrial facilities. A single campus can cover more than 100 hectares, house hundreds of thousands of servers, and continuously consume between 100 and 500 megawatts of electricity. To put that in perspective, the average electrical demand of a city of 100,000 people is approximately 80 megawatts. A single hyperscale data center exceeds that. In 2024, Microsoft built more data center capacity than in its previous 30 years combined. This is not an anomaly, it is the new normal. The central problem of data centers is not space, it is energy. In 2023, the world's data centers consumed approximately 400 terawatt-hours of electricity. That is more than France's total electricity consumption. By 2030, the International Energy Agency projects that number will double, reaching 800 to 1,000 terawatt-hours per year. The main culprit is artificial intelligence. A traditional Google search consumes around 0.3 watt-hours. A ChatGPT query consumes between 2.9 and 10 watt-hours, 10 to 30 times more. With 100 million daily active users, that adds up fast. Goldman Sachs estimated in 2024 that the Microsoft and OpenAI Stargate project, $500 billion in data centers by 2028, will require the equivalent of all new electrical capacity the United States plans to build in the next decade. But electricity is not the only resource under pressure. Data centers also consume water, in quantities the industry prefers not to publicize. Servers generate heat. That heat has to go somewhere. The most common method is evaporative cooling, water that evaporates to dissipate temperature. In 2022, Microsoft's data centers in Iowa consumed 6.4 million liters of water per day. Google reported 17.4 billion liters in all of 2022, just for cooling. The Netherlands reacted first. In 2023, it imposed a de facto moratorium on new data centers in the Amsterdam region due to saturation of the electrical grid and depletion of local water resources. Chile and Uruguay rejected data center proposals due to their impact on aquifers in already water-stressed areas. The paradox: the technology that promised to make the world more efficient is now competing for water with agriculture and human consumption. Data centers are not built randomly. Every tenth of a millisecond of latency has a measurable economic cost. That is why Amazon has data centers in Lagos, Mumbai, Sao Paulo, and Melbourne. Not for marketing, but because the time a signal takes to travel from server to user determines whether a financial transaction completes or fails, whether an online game is playable or not, whether a robotic surgery system responds or freezes. The three most important internet nodes in the world, Ashburn in Virginia, Amsterdam in Europe, and Singapore in Asia, control the data traffic of more than 3 billion people. China responded with the 2021 Data Security Law. All data from Chinese citizens must be stored on Chinese soil. Russia, Iran, and India followed with variants of the same law. Data sovereignty is the new national sovereignty. Artificial intelligence changed the physics of the problem. Training a large language model like GPT-4 required approximately 25,000 GPUs operating in parallel for 90 days, consuming between 10 and 15 continuous megawatts. Nvidia controls 80% of the data center GPU market. Its H100 chip costs between $30,000 and $40,000 per unit when they were scarce. And in 2023 and 2024 they were, with waiting lists of more than a year. Companies cannot grow. But there is a link more critical than Nvidia. TSMC. The Taiwanese company manufactures 92% of all advanced chips that go into the world's data centers. If TSMC stopped production from an earthquake, an invasion, a political crisis, 60% of the world's data centers would lose the ability to expand within 18 months. There is no real plan B. The industry is looking for solutions. Microsoft acquired the operating rights to 3 Mile Island, the nuclear plant that suffered a partial accident in 1979, to reactivate it and power its data centers with clean nuclear energy. Google signed contracts with Kairos Power to build 7 small modular nuclear reactors before 2035. Amazon invested in X Energy. The logic is simple. Data centers need energy available 24 hours a day. Renewables cannot guarantee that without massive storage. Nuclear can. Meanwhile, engineers are solving the heat problem through immersion, submerging servers in dielectric fluid, a fluid that conducts heat, but not electricity. Efficiency rises to 97%. Microsoft tested underwater data centers on the ocean floor off Scotland for 2 years. The result, 8 times fewer failures than on land. Data centers are the infrastructure nobody sees, but everyone uses every second of the day. They are the physical substrate of the digital economy, artificial intelligence, global communications, and modern military systems. And they are at the center of the most important competition of the century. Whoever controls compute controls the future. The United States and China are each investing hundreds of billions of dollars to ensure their data centers are the largest, most efficient, and most independent. The question is not whether the world will build more data centers. It is impossible that it will not. The question is who will be in control when the next generation of artificial intelligence powers on and where it will be connected.